everybody. So we're going to do some lecture content for chapter 1 of our textbook. So the first thing that we learn about is matter and energy and really how to tell the difference between them. But I have a more general question for you. I want to know what you think chemistry is. And so this is going to be our discussion number 1 for week 1. You're going to go in and just tell me the answer to these 2 questions. I'm not really looking for something like, because it's part of my major. I'm looking for something like, why do you think it's part of your major? Okay? We don't just choose random classes to put people in. There's reasons for choosing a specific class as part of your program. So I want you to think about what is chemistry, and then also, how does it relate to what you're going to do in the future? And then I had this text quote from our old textbook, which is called The Central Science, because chemistry is often the first science class you take in college for science and engineering and pre-med and stuff like that. That's because it touches on every other kind of science. And so that's why I like studying it. I get a little bit of everything. A little biology, a little bit of physics. And so that's my perspective on it. And I would like to get your perspective in the discussion week 1 post. So the universe is made of 2 things, matter and energy. That's it. And so if it's something you can touch, if it has mass and it has volume, you can interact with it, then it's matter. If it doesn't have mass and volume, then it's energy. So that's the first categorization. After that, we think about matter as being classified into a couple of different types. And so the most basic building blocks are called atoms. They're the smallest indivisible particle. That's what the word literally means, atom. Atoms are actually made out of protons, neutrons, and electrons, of course, and we learn more about that a little bit later on. For now, we just need to understand that neutrons have a mass of 1, and they have no charge. Protons have a mass of 1, and they have a +1 charge, and electrons have no mass, and they are -1. Okay? Elements are kind of a synonym for atom, right? So your simplest building block is an element. So really, when we say atoms and elements, sometimes they get used interchangeably. Elements refer to specifically any one of 118 different types of atoms, right? So here I have my handy periodic table. Okay. So as you see on here, there are 118 different elements. And this is kind of cool because it gives you uses for most of them. I got that at the fabric store. That's why it's made out of fabric. Okay, so I love stuff like that. And if you pay attention in my recordings, you might actually find quite a lot of periodic tables around me at any given time. So some of my favorite examples of elements are carbon. We're made out of carbon. We are carbon-based life forms, which means that a lot of our atoms in our body are carbon. As it turns out, that's not the most prominent by weight, though. Oxygen is actually a bigger percentage of our body because we are largely made out of water. But water is everywhere, so we say we're carbon-based life forms, not water-based life forms, although both of them would be true. Okay? So these are all different elements: oxygen, hydrogen, carbon, silicon, aluminum, iron, calcium. These are all different elements. And of course, we have some calcium in our bodies, but it's such a small percentage that it goes into this other category. Whereas if you're thinking about what the entire Earth is made from, calcium is actually a pretty large percentage of that. It's usually in the form of calcium carbonate, which is sand. All right, so calcium is an element, but calcium carbonate is a compound, which is one of the components of sand. It's also what like corals and shells are made out of, things like that. So calcium carbonate is 2 words, so it's a compound. Okay, we also call those molecules, by the way. And so other compounds you probably have heard of include things like glucose or carbon dioxide or even water, H2O. That's a molecule as well as a compound. Okay, so compounds are made when you take 2 different elements and put them together, like carbon and oxygen can either make carbon dioxide or carbon monoxide. And of course, they have 2 different properties, like sets of properties. They're completely different chemicals, so they behave differently. Elements are different one from another because they have differing numbers of protons, neutrons, or electrons. All right, so what I mean is, if I have two different oxygen molecule atoms, two different oxygen atoms, it doesn't exist as just plain O, actually, but we'll get to that in a minute. Then the oxygen atoms both have the same number of protons because that's what gives it its identity. All oxygen atoms have the same number. But what might be different is the number of neutrons and the number of electrons can vary between two different atoms of oxygen. The electrons are only going to vary if the oxygen has a charge, plus or minus. Usually it's a -2. Okay, so that's our initial kind of building blocks of the universe, right? And so in order to understand matter, we have to understand what mass is. And so mass is really resistance to being pushed. Okay, so if I take an object, I can push on it, right, and make it move. So here is my coffee cup. I can move that, right, just by kind of nudging it. If that coffee cup was made out of lead, it would be a lot heavier because lead is denser than ceramic. And that would mean I would have to exert more force to push it the same distance. That would mean the lead has more mass than the ceramic does. Okay, and so that's the basic idea. So matter has to have mass and it has to have volume. That's what occupying space means. Atoms are responsible for that. Protons and neutrons are largely responsible for the mass, and electrons are largely responsible for the volume of the atom. The protons and neutrons actually take up a very, very small proportion of the atoms. Most of the space is electrons, okay? And so all matter is made out of protons, neutrons, and electrons, which means all matter has mass and all matter has volume. Now, mass is interesting because it's constant no matter where you go, but weight is not constant. So here's a picture of my daughter when she was about 3 months old. She weighed about 4.3 kilograms. Do you know how to convert that to pounds? Is it bigger or smaller in pounds? I'm going to make that a bonus question on our video assignment, so make sure to check in with that. Anyway, so if I take my 3-month-old baby at the time, she's 7 now, who weighed 4.3 kilograms at that time, if I take her to the moon, she gets lighter because the moon it doesn't have as much gravity. It is not as large as the Earth. So the acceleration she is experiencing is lower, so her weight will be lower. The number of protons, neutrons in her body has not changed. So that means her mass has not changed, but certainly her weight has. So of course, if we go to Jupiter, which is much bigger than the Earth, she will be heavier because the same amount of mass is being exposed to a higher acceleration, a higher force of gravity, because Jupiter is bigger. If I took her to the sun, which would be a terribly irresponsible parenting move, but if I did, I won't, but if I did, she would weigh about as much as an average man on Earth. Same amount of baby, heavier because the sun is much, much bigger than the Earth is. Finally, if I take her to this really cool neutron star, which is really, really dense because it's collapsed, she would weigh that much. I don't even know what to call it. Billion? Million? Something like that. Anyway, she would weigh a bunch of kilograms, way more than an average man. Okay, and so that's the magic of gravity, and that's how it influences it. Most of the time in chemistry, we are going to use the phrases mass and weight interchangeably, but it is important to note it's not interchangeable. So if you become a chemist working on the International Space Station, you cannot simply measure the weight of things. It won't be the same on Earth. Okay. So this activity is a fun way of visualizing how different states of matter exist. So you can click right on this link, which I will also put in your learning check in your video assignment. And you can explore what a solid looks like, what a gas looks like, and what a liquid looks like. And I want you to be able to identify these questions in your learning check. These are also similar to the exercise we did in class.